So today we're just going to talk about the conditions that need to be met before you can run a confidence interval or a hypothesis test. So there's four things to it, okay? And it's kind of like the central limit theorem, but the central limit theorem you were checking to make sure that you could use a normal model. And here you're just verifying that you can use a linear model, okay? So the first step is to make a scatter plot of the data if you don't already have one given to you. And just check to make sure that the pattern is pretty much aligned, right? It's fairly linear. So here's an example that meets that condition, and here's one that does not, right? Because it's pretty curved. Then the second step is to check that there's equal variance throughout. So you can look at the scatter plot and just make sure that the dots are about the same distance above and below the line, right? Nothing's too crazy out there. So you can check the scatter plot, or you can check a residual plot. So again, you have your least squares regression line here, and then your errors, your residuals, how much above and below were we off. So again, just making sure that the variance here at the beginning is pretty much the same in the middle and the end, okay? So this is an example that meets that condition. You can also just write down that the residual plot shows no pattern, okay? Or again, if you're just writing there's equal variance throughout, you can just talk about the scatter plot. They're about the same above as below the line. And then here's an example that, again, does not meet the condition. Obviously, you got a pattern there in your residual plot. Now, I wanted to note, how do you know if it's a residual plot or a scatter plot? So it tells you on the side here, that's why I have these highlighted. So you have a residual values, it'll tell you, I know you can't really see what these say up here. I don't even know what they say. Life expectancy, and then who knows, okay? But it doesn't say residual. It'll say residual if it's a residual plot, all right? Then the third step is to check that the distribution of the residuals is approximately normal with no outliers. So just a reminder of that shape. What does normal look like? You got the peak in the middle. It's fairly symmetric, and then one that wouldn't work. And again, this is for the residuals. If you don't have a residual plot, you can make one, but usually they will give you one, or you can just check that your sample size is larger than 30. Okay, so if your sample size is more than 30, then you're good. You don't have to worry about a residual plot. Okay, and then the fourth thing you need to check for is independence, and to verify that the data came from a random sample. Okay, so you look through the question, make sure that you got a random sample, that way you can generalize to the population. And then for independence, you make sure that your sample size is less than 10% of the population. So you just take 10 times your sample size, and again, make sure that's less than your entire population, whatever it is they're interested in. Okay, so those are the four conditions. And then I just wanted to kind of go over some vocabulary with you guys. So sampling variability, just a reminder that each time you take a sample, your results are probably going to be a little bit different. You're not going to have the exact same results. That slope is change in y over change in x. The y-intercept is what was predicted for the y value when the x value is 0, right? So if x is 0, what do we expect the y value to be? Then S sub b is your standard error of the slope. So if you took a bunch of samples of the same size and you calculated the slope of the regression line for each of those, it's telling you on average how much those sample slopes tend to vary from the true slope, right? From whatever's true about the entire population. Okay, and then S here is going to be your standard deviation of the residuals. So before we talk about this definition, I wanted to talk about what a residual was, in case you forgot. So the residual is really just the error. You take your actual y value and then you subtract whatever your least squares regression line predicted the y value would be. So it's basically just telling you how far off the prediction was from the actual y. Okay, so the standard deviation of the residuals is on average how much the actual y tends to deviate from the least squares regression line, right? The predicted y value. Okay, that's all. Go ahead. ahead and talk about number one. That was asking if all the conditions were met for linear modeling. So the first thing you had to check was your scatter plot fairly linear. So you come over here and you can see that pretty much these dots are following a straight line. So that one's good. Then the second thing you needed to check if there was equal variance throughout. So you could have written there's equal variance throughout the scatter plot, which you can see here, right? The distance between these dots and your line is pretty much the same, again, in the beginning, in the middle, and the end throughout, okay? I did not write that. I chose the second option that you can just look at the residual plot since they gave it to you here and see that there's no pattern, right? So there's no pattern in the residual plot. Just to make sure you know which one's which, right? It tells you on your y-axis, it says regression residual, and over here you have happiness rating. So this is your basic x and y here. Okay, the third thing you needed to check was that the distribution of the residuals was approximately normal. You don't want to make a histogram of all these residuals, so you just check the other option, which is that your sample size is larger than 30. Okay, so up here it says he surveyed 100 students, so that is definitely more than 30. So that's good. You don't have to worry about making a histogram of the residuals. Okay, and then the fourth thing you needed to check was independence, right? So is 10 times your sample size less than your whole population? Yes, right? He's looking at students at his university, so all the students at the university is definitely more than 1,000, right? 1,000's less than all the students at the university. Okay, and then don't forget that you also have to make sure that there was some sort of random assignment, random sampling going on. So it tells you up here that John randomly surveyed 100 students. So all four conditions check out. So yes, the conditions are met. Okay, let's talk about number two. Was asking the same question. Are the conditions met? So the first thing you check again is your scatter plot fairly linear? Yeah, kind of, right? It's not the greatest, but we could say that they're following a line, right? Be pretty lenient, all right? And then the second thing you had to check though was there equal variance throughout? So you can see in both of these, the scatter plot and the residual plot, that it's fanning out. Okay, in the beginning, there's not a lot of error, but as x increases, you're getting a lot more error. Okay, so no, there's not equal variance throughout. You could put that there's a pattern in the residual plot, fans out, or you can write what I wrote here. There's more variance as x increases. Okay, so that doesn't pan out, which means we don't need to check 3 and 4. Are the conditions for linear modeling met? No, they're not. Okay, so let's look at number 3. So part A asks you to write the equation. So you're going to start with your y, proportion of perch killed, and don't forget to put the little hat on it because it's a prediction. And then that equals your A, your y-intercept. I got that from over here, 0.12. The constant. It's a little hard to see here in the video, but if you go to your guided practice, the blank one, you can see it a lot better. Okay, and then your plus b, right, your slope. So you come over here, what's your slope? 0.0085, so I just rounded it up to 9. And then your x, okay, so the number of perch in the pen. For part B, it asks you to predict the proportion of perch killed in a pen that had 25. So you use the equation here and just plug in 25 for your perch in the pen and plug it in and you should get 0.345. Okay, part C, what's the estimate for beta, right? Your population slope, it's just your sample slope. Okay, so the 0.008569, so rounded again, 0.009. And then it asks you to interpret it. Okay, so how's your y changing for each x? So I come back up here, what is y? the proportion of perch killed tends to increase, since I have a positive slope, by 0.009 for each additional x, right? The number of perch in the pen. Okay, D asked you what is the standard error of the slope, and then again to interpret it. So the standard error of the slope is right here next to the slope. See how it says standard deviation? So 0.002. And then what does it mean? That sample slopes, right? If I did a bunch of samples and got the slopes from all of those, they're going to tend to vary from the true slope by about 0.002. So not a lot of variation. Okay, and then part E asked you to interpret S. Okay, so S is your standard deviation for the residual. It's right here. Okay, so on average, your Y value, the proportion of perch killed, tends to deviate from the values predicted by the least squares regression line by about 0.1886. Okay, and then finally for F, what's the estimate for A? That's your y-intercept, your constant up here, the 0.12. And again, remember it's when x is 0. Okay, so when there's no perch in the pen, number of perch in the pen, when there's no perch in the pen, the predicted proportion of perch killed is 0.12, which is impossible. There's no perch in the pen. How can you have any of them killed? There's none of them, right? So just add a little note to that. That's fine. Interpret it and then just put a little note. That doesn't make sense, okay, which is totally fine. We're extrapolating, right? We're probably going outside of the data. He only had 10, 20, 40, 60. We shouldn't go outside of those x values. One, number 4. So what degrees of freedom should he have used? So remember that for these inferences for regression, you have to take your sample size, 57, and subtract 2, because we don't know the slope and we don't know the y-intercept. We don't know two things, okay? So the degrees of freedom should have been 55. Then part B asks for an interpretation of the interval, of the confidence level. Sorry, big difference. Confidence level, not the interval. So the confidence level is this 95%. What does that mean? Okay, so that means that if we made a bunch of confidence intervals, about 95% of them are going to capture the true slope. Okay. Then part C, now it asks you to interpret the interval, which is right here, right? So we're 95% confident that the true slope relating y and x, you always again want to add some context. So just say, what is the slope talking about? It's relating the y, the daily over-the-counter steroid nasal spray sales, to your x, the forecasted mulberry pollen count. Okay, so that true slope relating those two things is between what two values, and where did 0.16 and 0.58, where did I get these from? I just subtracted, right? 0.37 minus 0.21, that gives me my lower bound, the 0.16, and then 0.37 plus 0.21 gives you the upper bound of 0.58. And then I just put units, okay? So your y over your x, y is measured in dollars, x is measured in particles per square meter. Yeah. Okay. If you don't put those, I don't think it's a big, huge deal. All right, and then D. Based on the interval, is there convincing evidence of a linear association between the forecasted mulberry pollen count and the daily over-the-counter steroid nasal spray sales? Yes, right? Make sure you answer the question, put yes or no, and then an explanation. So yes, because 0 doesn't fall in the interval, right? Remember, it goes from 0.16 to 0.58. 0 is not in there, so there is enough evidence to suggest a linear association between, and then I just copied the question here, okay?